right. Well, Aaron, do you want to introduce yourself to the group and go ahead and take it away?
Yeah, sure. Thanks for having me on today. I appreciate you guys taking the time to hear a little bit about what we're doing with Trellis and the Open Ag Data Alliance. So I titled this talk an abridged introduction of kind of complicated diagrams because Dennis told me I could be slightly more technical than normal here. And so hopefully we don't get lost in them. But I think they're kind of important to understanding sort of data flow in agriculture, that the nature of the beast is that it's complicated. And I kind of feel that myself, at a personal level, because my background is I'm first and foremost a farmer. And so I've got about 3,500 head of beef cattle that I raise in those barns at the top of the picture, and about 3,500 acres of corn and soybeans that go in the bins down at the bottom of the picture down there. And that's kind of my day job. And then also got my graduate degree in computer engineering from Purdue, and helped co-found the Open Ag Technology and Systems Center with Dennis and Jim several years ago. And we did that because we realized, or I was really interested in it, let's say, because I realized that both sides of my life, coding and farming, data was a pain in the neck. And we said that, the reason it was, the primary missing thing was open source. That, when I coded in the tech world, I was standing on the shoulders of people much smarter than me that had done a lot of great work to build compilers and, web frameworks and things like this, that when you got to the ag space, you were kind of floating alone. And so one of the nice things to see in the last several years is there have been these, creations of communities just like the one you guys have right here, where there's actually, tech people meeting around trying to spur data movement in agriculture. And I think that stuff's really cool. So that's part of what we try to do in Oats as well. And our sort of guiding principle here is that what farmers really want from data is that it should flow from wherever it starts to wherever they want it to end up without manual intervention. They don't want to touch the bytes. And data in agriculture thus far has felt a whole lot like you're carrying buckets of bits from one place to the other, and bits aren't meant to be carried. They're meant to flow on their own. Of course, we're ag researchers at Purdue too, right? So we collect data from the field. Dennis's Wind Project does this a lot, right? And it turns out that's exactly what ag researchers want from data too. We don't want to have to mess with it. We just want as slick a pipeline as possible from where it starts to my MATLAB chart without me driving 2 hours to the field to collect a bunch of data off of a hard drive somewhere. It turns out to be what the machine learning community is interested in too, right? Like, to start machine learning, you need data. That's step one. If we don't have data and labeled data, then we can't really do what we want. And so that's sort of just the table stakes. It's the stuff you have to do to get to do the stuff you want to do. And actually, it turns out this is what everybody wants from data. We don't want to have to mess with it. We just want it to sort of serve our interests or answer our questions without having to think about how it gets from A to B. Or in one word, really, automation. And it's kind of interesting because in ag, the hardest thing to automate, or the easiest thing to automate, you'd think would be digital, right? Like the bits, the data is already digital, so it should be easy to automate what we do with them. And yet that's sort of the last frontier of automation in ag. We already have machines that drive themselves using satellites in space. Like, we got that before we could share data from one platform to the other easily. And so one of the reasons that is that a lot of folks in the ag industry sort of grew up around this one-size-fits-all approach to machinery, and they applied that to data. And so this is the approach most of them take for how we would automate data. And you see this in ag conferences and ag tech conferences. One guy gets up and he puts his slide up there, and their cloud is in the middle. And they say, hey, when everybody sends all their stuff to me, to our company, then we'll make everything interoperable. We'll make sure it gets where it needs to go. And then everything will be automatic and you won't have to worry about data anymore. And that's, everybody gets excited. They all clap, and that guy sits down. He did a good job. Next guy stands up, puts the exact same slide up, but his cloud's in the middle. And I always wonder, did you see the other guy's slide? Because his slide said his cloud was going to be in the middle, right? Like, they can't both be in the middle. So how does this exactly work? You know, and of course the farmer sees this a lot of the times and thinks, yeah, I'm going to sort of tie the mast of my farm ship to your company. And then when you get bought, you get, you know, the company that buys you says they don't really care about my farm anymore. And suddenly I'm kind of up a creek. And so the farmer kind of sees this, one cloud to rule them all, and in the darkness bind them. They don't want that vendor lock-in as much as possible. And of course, the flavor of the day, that went from cloud to blockchain now. That like now we'll all just send ourselves stuff to the same blockchain, and then all of our problems will be solved. And so we're trying to work in this space is like, how can we achieve the data automation that we want without the centralization that we don't? And that's what the Open Ag Data Alliance framework and Trellis are about. They are an API framework that you can deploy and implement anywhere on any system that essentially allows those two systems to communicate. So you can deploy it as a VM on Azure that's talking to your own, databases in the back end, and that's how you sync out to 3 of your partners or something like that. Or you can, buy it as a managed service from someone. It's sort of, because it's an open source thing that you can just install, it's available for everybody. And so what does that look like? What does the picture of ag data look like in the world where it sort of flows automatically and it's no longer such a pain to get data from point A to point B? Well, I may start with like a combine over here that's it has field boundaries, it's creating yield data, it's got a bunch of machine information that's streaming to the cloud. And in this case, it's the OEM's cloud. They tend to think very highly of this link. They want to own that as much as possible. And so most of this stuff goes to the OEM's cloud first, wherever it may be. And then I can look at it on my tablet or on my computer and see my yield maps and yay rah. And then all of a sudden a new startup comes along and says, hey, we're machinehealth.com. We think we can give you better insights into when bearings are going to go out or when you need to service this machine, or we can use AI to analyze the data coming off the machine and help you do a better job of planting or spraying or whatever. And they say, all we need you to do is just get us the data that's coming off that machine already and get that over to us. And without sort of automated data, that process would be you going to this OEM's cloud and clicking export and emailing them a zip file. And if you want it real time, you're just going to do that every 15 seconds. And that's probably not going to happen while you're combining corn. And so in the world where the data can flow, though, all of a sudden there's a market. Like before, there was no market for machinehealth.com. Now, when it's just the farmer can essentially say, I just want my data to end up at machinehealth.com, and machinehealth.com and the OEM don't have to agree on that ahead of time. It's the owner of the data, the farmer, that sort of drives that connection. Then as soon as he's got a few different services sharing data, he's going to naturally gravitate toward wanting his own sort of cloud of choice, right? The place where he tries to get all the other things that make data to push it into there. And then from there, he'll push it back out. The important thing to understand, though, is that not all farmers are going to pick the same cloud of choice. So for this farmer's world, it's easier to see a centralized place that all things flow through, but it'll never be such that that's the only cloud in agriculture. And so once he's got it, now the sky's the limit. Now there actually is an ag data market where there wasn't one before. He can have field sensors made by one manufacturer whose data flows into his cloud and then gets pushed out to the recommendation service that's creating his nitrogen recommendation maps. Or his machine data from his combine flowed through the OEM's cloud into his cloud and on down to a logistics management service, for example, that just helps him manage where are all my machines at, things like that. And, same kind of a thing. His apps can pull in university data to say, how are your fields doing, that kind of stuff. And then on that, there's beyond his own farm's boundaries, the co-op that does a lot of fertilizer application for him or does his soil testing and things like that. There's this sort of complicated internetwork. It's, it would look rather distributed just in this picture of how data gets from A to B that the farmer doesn't necessarily think about, right? He just sort of sets this up ahead of time. He says to the OEM, I want you to push your stuff over here. And then he doesn't think about that one anymore. The yield data just ends up over here. So he doesn't sort of plan this out. It just gets made as ad hoc as he adds more service providers. And then, of course, in this sort of a world, blockchain is in the center. It's like one of the other things that you may send stuff to if you want to certify your produce is organic or something like that. So the basic extractions that make up this sort of a picture is you have to have an API connection that makes sense to everybody at each stage of those places. And that's what, of course, Trellis provides. You have to have microservices or services. Usually we call them a service if they're outside of our company's boundary, and a microservice if they're in, is how I've seen a lot of people use the two terms. But the idea is there's got to be real-time processing in there somewhere. There are going to be storage and caching layers. This is a really important thing, that this picture is primarily a caching problem. that I have data here that also lives here, that also lives here, that also lives here, and they need to be kept in sync. And that's a tough problem to do if you don't have any kind of coordination. And then lastly, none of this works if you don't have open source, because you can't gain any of the sort of operational interoperability that you need for two places that have never talked together before to be able to actually do the hard job of cache coherency across them. So what that means is, as we've designed real systems with this thing that we built, we've noticed that Elata and Trellis, it actually serves as a sort of engine for microservice architectures that cross platform boundaries. So the farmer essentially needs his own little microservice architecture to work, but he's got different companies implementing different parts of it. And Trellis is the thing that lets you sort of push these things around from platform to platform to platform. So what it really is, first and foremost, is we say a model or a format agnostic API spec. So that means if you give me a data model, I'll give you back a real-time two-way syncable API. The API handles authorization, single sign-on permissions, discovering resources at a cloud you've never connected to before, change feeds for how you can register to get new yield data as it comes in, for example, handling concurrency with optimistic locking, indexing. So how do you find the little bit of data you want out of the larger data set? All those sorts of things are handled by Trellis. But what's not handled is the thing no one can ever agree on, which is what format the data should be in. And so we essentially say, specify the format, API follows from that. So how that can look in this scenario is you already have a service and you have an API that you're talking to the world, and you've got a few people that want to connect to you via Elata or Trellis. I didn't specify, but those two names are really just different brands for the same thing. Elata is in row crops, Trellis is in the produce industry, and it turns out to probably be the one in livestock as well. But essentially, the world is, you could stand up or implement a sort of facade in front of your own cloud or in front of your own API that just translates the API spec into calls to your own backend. The other thing that Oat and Trellis is an actual open source reference implementation. So like if you want to run it in an Azure VM, for example, you just turn on a VM, you need at least about 4 gigs of RAM, clone the code base and run this one command, and voila, you have an OATA instance running that you can connect up to other things. It runs in Docker, so it's sort of agnostic. It's pluggable, so you can write things to override core functionality, and it's extendable, so you can just drop in anybody else's services that they've written, and they'll just come up with your OATA instance at the same time.
Aaron, can I ask a quick question?
Sure.
Who is you in all this? Is you the cloud provider, or is you the farmer, or you is the developer?
That's a good question. And the answer would be all of the above. So I, as a farmer, could stand up, for example, a MySQL database to store my stuff on my own machine on my farm, or on a Raspberry Pi in my tractor, or I could install it in the cloud, or I could choose a managed service to do it. It really depends. Now, it takes a fair bit of technical knowledge to turn this on, the same way it takes a fair bit of technical knowledge to install MySQL, for example. And so I don't anticipate non-technical farmers to install and run OATA until we have a significant amount of funding to make that user experience really seamless. And so what it will tend to be is folks that are sort of aggregators, or some of these other services that are providing simple services for farmers, or single services for them that want to become more interoperable with others. Does that make sense?
Yeah, thank you.
Okay, good. Thanks. Good question. So the other way that you can do this, and this is actually the way that we've done it in every single commercial installation that we've had, is most of the time they would rather leave their existing API implementation in place, and we treat the OATA open source implementation as a caching layer of the stuff that they're serving over the API this way. That way you don't have to actually implement all the difficulties of making sure your API implementation conforms to OATA. You instantly conform to OATA here, and you just need to write a single synchronization service to sync over what you need into the cache. And then what Oat and Trellis is beyond just that reference implementation is a growing set of useful microservices that are open source that can speak the Trellis and OATA language. So you can just turn on, for example, abalone mail, and you now have something that if anybody posts a job to a particular endpoint in Trellis, it will send emails for you via SendGrid. or Trellis shares, that you can create some rules that dictate when this data comes in, I want you to automatically share it with these other people on the local platform. Or notifications, it says, hey, when I get a new food safety certificate to come in, I want you to email me, that kind of stuff. And so currently we've got some active enterprise deployments for Winfield United and row crops, which I think announced a partnership with Microsoft just the other day. We've also got Centricity. These are both two of our board members within the Oats Center that they do Trellis as a service. And so they've got several different clients working with on that. And they tend to focus on specialty crops. And we have an active enterprise deployment with Smithfield, the pork producer, that is really focused on supply chain. How do we use Trellis to move food safety data, shipment data, that kind of stuff through the supply chain onto different blockchains, things like that. And then finally, it's a set of published data schemas and content types that are sort of a model that doesn't say, it's not prescribing those are the ones you have to use. It's just saying, here's a published one that works. If it works for you, you use it, and it'll become a popular format. And so you specify them generally in JSON schema, and then it can automatically compile and host things in TypeScript in GitHub for you. So then you can point all your TypeScript stuff at them, and it tends to work well for us anyways. So that's the sort of the high level of what it actually is. So I'll give you an example. So with Winfield United, we wrote this open source app called the Fieldwork App, which its main job was just to really simplify the process of managing which fields you were going to plant today and which fields were done, so that you can kind of see up here at the top, like the green means we're 57% done with bean planting this year, and the yellow means we're 28% started or they're working on today. We got 15% left to go. That's what the red means. And you just get a nice map of all your field boundaries, and you can just tap on it and say done. It's intended to be something as quick and painless as possible, but it gives you some information in the moment that's valuable to you while you're managing your day, which says, well, how far do we actually have to go? I mean, the rain's coming tomorrow. Which fields should we prioritize over other ones in a kind of nice visual sense? So this app runs completely in browser. It doesn't have a database. It assumes you have your own OATA backend somewhere. And so when you bring it up in the browser that GitHub Pages hosts for you, you just point it at your OATA backend, and voila, it now has a cloud, and it can do all of the real-time sync across all your employees on the farm. And other microservices can then look at like machinery tracks, let's say, to see that your machine went into this field and automatically mark it as done for you anyways, because, or at least started because you went in there. And so one of the OATA backends that you can connect it to would be Winfield United's data silo in that scenario. Another one, this is more of the complicated diagrams. And this, we're going to wrap up with this, is the food safety supply chain. That's what Trellis, kind of where Trellis got its start, in that there were a lot of companies that needed, the way they exchanged food safety data was essentially a person gave a phone call to another person at a company, and they would email them a food safety certificate as a PDF file. And that was, worse than useless, because it just took a bunch of time and no one ever read them. Yeah, like all they really cared about was the score anyways, but you couldn't do any analytics on them. And it tended to mean that across multiple organizations, you never had the latest copies of these things, even though from a food safety perspective, you're supposed to. So the installation that we've put up at Smithfield, for example, that they have their own Trellis instance here. They have an app named Conductor that's open source, that's up in GitHub, that you can just point at your Trellis instance, and it sort of manages the relationships or the interworkings of all these other services that are all open source and all talking through their localized Trellis instance. Now, one interesting thing about Smithfield, I think, for this call is this is all deployed on Azure. So we're actually going to be building some scripts and things to significantly simplify that deployment process. So hopefully it's soon to the point where on Azure you could just say, I need a Trellis VM, and you have one. But it's not there yet. So the way this works, though, is that PDF document that would come into Smithfield, we get it into Trellis. You can either email it in, or you can, it comes in via SendGrid, or you can drop it into Conductor, and Conductor will upload it to your Trellis cloud, and there's a few other ways that we can pull that data in. But the basic idea is a PDF document shows up. It's one of these food safety certificates that says, hey, that facility is safe to produce food for this year. It goes out to a managed service by Centricity, which is a microservice named Target that they sell, that it sees the PDF show up, automatically scrapes the whole thing and turns it into JSON and signs it. So it's got a digital signature, so you can't forge it later on in the supply chain, which is actually a bit of a problem today. But it does this automatically. So the PDF shows up, and a couple seconds later, you've got JSON sitting in your Trellis cloud. Now that you have JSON, though, you can actually write rules that say, well, we ship stuff from this plant to this customer, so we should just automatically send a passing audit from that was for that plant over to that customer. So the way that that works is we've got a set of facilities here, and we've got a set of local users that they've created for each customer on their Trellis cloud, and Trellis shares, executes some rules, sees the thing show up based on the facility that they have, and shares it to these two guys, but not that guy, because he doesn't get shipments from that facility, for example. This guy then has the Trellis notification service configured so that when a new document shows up, he gets like 3 people at their company get an email, which then goes through Abalone Mail to send it over SendGrid. And then this guy, he's configured, actually, there's a component of Trellis that we call Mask and Link, which is open source. They can take any arbitrary JSON document, and it can essentially do like the CIA top secret blackout on it, where we mark out the parts that are like personally identifiable data that we don't really want to share, but it carries along with it a Trellis URL and a hash, so that anybody that receives the blacked out document later, it points back to Smithfield's cloud, and if Smithfield gives them permission, then they can actually audit and verify that the document they got was the correct, all the data behind the scenes hasn't been modified since we got it. So that means Smithfield can control their data sovereignty. They can say, we want to share this kind of data outside of our company boundaries, but not this kind. And then when that gets shared with this local user, he's been configured that he wants food safety certifications to go to FoodLogic and also to the IBM Food Trust. So we've got these 2 integrations published open source as well. So anybody could point the FoodLogic integration at their Trellis cloud, and it would sync over into this particular supply chain company into their database. And then when it comes to the Food Trust, maybe somebody then wants to actually access and audit that masked information from the original document. So there's a public app that we call Reagan that we published, which is Trust but Verify. So when you click a link in the document over here that got delivered to Food Trust, it takes you back to Smithfield's cloud through this app, at which case then you have to log in, and then it can all do the verification for you automatically. So that is an overview of what we do with Elata and Trellis within the Oat Center.
That's great.
Wow, thank you. That was a great presentation. Lots of really good information.
Thanks. Are there any questions?
Yeah. So Trellis and Open Ag, are they the same or different? I was not quite sure.
Yes, they are the same. So the Open Ag Data Alliance is the original name for the project. And then we were originally funded in the produce industry by the Produce Marketing Association. And they wanted a non-row crop name for what this is. And they came up with the idea of Trellis, which is a better name than Elata, to be honest. But we had both at that point in time. So now we live with this dual brand. But yeah, they are the same thing.
Well, I suppose if you're not in computer science, it may be a better name, but computer science, Open Ag, maybe better. Because my question is, did we just create another cloud? Like, does everybody need to speak Trellis now?
Oh, that is a good question. Yeah. So have you ever seen that XKCD comic about standards? No. Okay. So it's basically goes that most of us look at some particular area that is, it says, oh, there's 14 different standard ways of doing that thing. That's crazy. Let's make a new standard so there's only one. And then when you're done, there's just 15 standards now, right? And version 2 of your own standard competes with version 1 of your standard even then. Like you just can't get away from it. And so what we said was that the interoperability problem isn't solved by forcing everybody to speak the same language. But if you're in the ag industry and you have to do API integrations, and like let's say there's 75 companies you're trying to integrate against on a large scale, you have to implement their API anyways. If one of them picked Trellis, it's no skin off your back whether they pick that or their own API, right? It's going to be the same amount of work. But if 2 of them pick Trellis, then at least those 2 of the 75 have saved you a little bit of work. And some of these, open source tooling and things that are out there have made things a little bit better. So we certainly don't ever claim that it would ever be the only way that things happen. But there aren't a lot of competing API specs out there, to be honest. If you are a developer and you want to do a high-level user experience that involves real-time sync of data, what are you going to ask the guy who's creating the data to do for you? Like, you need to ask him to make this API, like a particular API. And so there may be some, but Trellis is sort of one of those that that can be in that mix. So,
and my last question is so then you applied that the source code for the containers and different tools are open source. Is that correct? And then the last one
yes.
But the data itself, though, would be proprietary. It'd be owned by the farmer.
Correct. Yes, that actually, I should have said that first because we get that a lot, that the Open Ag Data Alliance is not about open data. It's about open source tools that interact with your private data.
Got it. Thank you.
So Aaron, along those lines, as you're kind of thinking about the future, what is the sort of vision in your mind about open data? Like, how much data sharing do you feel like is necessary? Because a lot of this is like within the farmer's view, sharing data with different services and getting information back. But how much data sharing perhaps would benefit farmers overall across different farmers? So what is the sort of open data plan for an open ag world?
So we have a sort of guiding principle that we post up with Elata that said that our central guiding principle is that the farmer owns the data generated on their farm. And so if the farmers themselves see that there is value in pooling data together, then great, they do that with the data that they have. We're not there to prescribe that for them. It turns out they do like to do that kind of stuff because there are several different benchmarking services out there, for example, that if you can wire your data up to them, they can tell you how that little spot in your field did compared to the other, 500,000 spots that other farmers uploaded into their platform. And so we were sort of along the lines of a lot of the folks in the data privacy space were trying to prescribe privacy, to say this is the one size fits all right way to do privacy. And we sort of said, we took the more, libertarian approach, I guess, that said that the farmer owns the data. It shouldn't be on us to tell them how they have to share their data. In fact, we should be putting them in charge of it, because a lot of the times they felt, we farmers feel at the mercy of the companies that make our machinery. We have no say in what happens with our data. And part of that is because we rely on like John Deere and, let's say Climate Corporation to have created a business deal ahead of time to integrate against each other. So unless those 2 companies agreed to do all of that work, I can't get my data from John Deere to Climate. And so I'm sort of stuck as a farmer with desires for data sovereignty, but in a complete inability to act on them. So.
Yeah. And just along those lines, when it comes to research farm, like, university research farms, do you find that there are more compelling reasons to share data across researchers, or not necessarily?
Oh, yeah, absolutely. Yeah. I didn't cover that in here, but we had seen probably the way that most researchers would deal with data is they need it automatic out of the gate. That's one of the things they miss. They feel like that they leave the cloud implementation stuff till later because that's hard, and you end up with just all the manual data collection first. And we kind of say that if you can push some of that automaticness down to the original data collection, then the sharing between researchers within your own group, for example, is one permission add. The sharing between groups of researchers is another permission add, right? We're just configuring our Trellis cloud for our own group to push it to the Trellis cloud for another group. And then when the project's over, we publish the paper and we want to put it up live, what most of us do would be zip it up in a giant folder that only the grad student understands and publish it on a website somewhere. And that doesn't really work if I'm going to go download what I want is to go clone your code from GitHub that the paper referenced and run the tests. and they're pointed at the API that's still up and live that you used while you were working with it, right? Like you just sort of change the permissions on it. So I absolutely see that as the model that I think works the best for sharing among researchers. And then the code you wrote that while you did the research turns out to be completely usable by others after you're done.
Right.
Yeah, that was a really nice progression from sharing within your own group onto the others within your organization, etc. Because that is a hiccup in today's world, where one grad student leaves and the next one picks up, and the files are in assorted formats, and what a mess. We could do better, for sure.
Mm-hmm.
That's great. Any other questions for Aaron?
So this is Abe Strook from Cornell. Thank you. Very interesting and impressive. Following on Elizabeth's question about the research context, do you have a current or past example of for example, in the phenotyping, genetics and breeding context, who's engaged with you and taken on as part of collecting and processing data to the cloud?
You're saying, have we done that with someone, or do we have a path to do that with someone? Which were you asking?
Well, I'm interested if both. I do. If you haven't a group that's engaged with you, that'd be great. And or if you feel like you can accommodate it, that'd be interesting.
I think we can accommodate it. One of the struggles, as you know, with phenotyping data is the massive amount of it, right? The massive size. So I think there's some interesting systems level work to be done to support this kind of movement of data, given terabytes of stuff and not gigabytes of stuff. But we have not had an active project in the phenotyping space that we've coded through Trellis. We've done some phenotyping things before, but our group itself hasn't worked on that yet. So we're open to those kinds of things, because I think that's where some of the really interesting data problems go at the moment. So is in that area.
All right, good. Well, we'll keep it in mind. Thank you.
Great.
Great. Well, thank you so much, Aaron. That was really interesting.
Thanks.
Appreciate it. So we have next on the agenda, we have Alex Vasquez, who's over there on the beach. Alex has joined us today. He's actually been working with our team for quite a while, helping get some of our new researchers and students up and running on Azure. So we invited Alex to just come and just say a little bit about some of the things he's done to help. And for this group in particular, we've come up, I guess, in the past conversations like, hey, could we have a session maybe on, understanding Azure IoT and what some of the tools are, or, can we do a little deep dive in creating dashboards, things like that. So we wanted Alex to give like a quick overview of the kind of training and things that he does. And then, for this group, if there's interest in pulling together a little session, maybe with a group of the students or some of the researchers that are, doing things, if there's particular areas of interest, that's something that Alex would be open to doing. So go ahead, take it away, Alex.
All right, thanks, Elizabeth. So, welcome to Virtually Me, everybody. Yes, it's sunny here in Ohio, which is where I'm based out of. So, I figured to bring a little bit of that sun to the meeting as well. It's interesting, as Aaron mentioned, even his solution, there's lots of different clouds. They have lots of different components. As you build out your solutions, whether you're developer, researcher, really there's so many options at times for how, when you're looking to do X, when you're trying to do that, okay, how does existing technologies work that allow you to do that? So one, that you're searching and just trying to discover what's available. But then on top of that is, once you find it, is how do you use it? And so really where I've been helping Elizabeth through the university relations team, and I may have spoken to some of you as well on the call, but really where I try to help is in helping you become familiar with the tools that are available to you on the Azure platform. Some of that may be, how to do something, how to get started. Are you running into a technical issue, perhaps that you're working with support on, but it's not getting you anywhere. So really, what I want to let you know is that if you're getting stuck, if you are seeking to get started, even maybe you're at the beginning of your project or your project's moving forward and you're looking for a better way of doing certain things, or you're not as familiar with one particular tool set, to reach out. I'm working with a team of cloud advocates behind me that our aim is to help you become familiar with the Microsoft tool sets, as well as many open source offerings that you may be working with. So whether it's you're a grantee, whether you're just looking for getting started, these are areas that feel free to reach out, and I'm here to assist and at least coordinate. So many of our grantees, sometimes they'll get their initial subscription, but then they don't know what to do from there. So what I help is kind of give that white glove support where I'm with you, right? I'm a person you can talk to. I help you go through the architectural guidance of a solution. What are you trying to do? Okay, here are some of the options. Here's how they work together, and really help you kind of formulate the picture of the solution you're trying to build. So that's really my role. So I really just want to make sure that everyone on this call was aware of you can reach out to the team, and then we're here to really assist you as best as we can. Even if it's helping to escalate existing issues that you may have run into and have submitted to Azure support, so to speak. So we do provide you with that architectural guidance, as well as suggestions and solutions from a technical perspective. Now, when it comes to, like Elizabeth mentioned, we are looking for, what do you want to know about? What do you want to hear? And so as you kind of think through, like maybe there's something you really want to know, feel free to bubble that up through this group, through Stacy, through Elizabeth, or through any of the links or email that you see on the screen. And we'll be happy to formulate a session specifically targeting that, whether it's a one-on-one session, or if we get enough requests, maybe it makes sense to do a group session as well.
Great.
Alex, maybe can you provide some examples of what questions we might ask? Because I know for me, sometimes it's like, I just don't know what to ask. I don't know what is out there. Are there any specific examples you could provide the group where they might think, I'm not sure who to ask about this? What would be an example question?
Well, an example would be once you start getting going with Azure, and you start thinking, okay, I see all these storage options. Which one is the most efficient? Which one is the least cost? Which one is the one that kind of really fits my needs, so you don't you don't sign up for the fastest, most expensive storage? That would be one example. Or let's say I want to share some information that's on a storage account with a group of other people that are researchers at other universities. How do I do that securely to make sure that we're not opening up any holes and releasing the data to the wild, so to speak? That would be an example of some. I've gotten in regards to FarmBeats, so just some questions in the past where when you're looking to stand up FarmBeats, you run into issues like, oh, I'm getting this weird error when I'm trying to deploy it. Why is that? What does that error mean? So if you're running into any of those, you can feel free to reach out as well.
So my colleagues wouldn't have this sort of a question because it's what they do, and Aaron already alluded to making it work. But some people like me need an Azure 101, maybe even Azure 001. Like, where do you start? Maybe, is there existing documentation or videos, that sort of thing, that someone like me could start with? That way, then I could come back with some intelligent questions.
Well, that's exactly what I'm here for. It's to help you get started. And whether you've never touched Azure cloud technologies before, we don't want that to hamper the research that really is the primary goal for why you're even evaluating or using or trying to use the cloud. So helping you get started even at that level, I'm here to help you step by step. And as questions get more complex and there's areas where I simply don't know, I have a team behind me that can pull in and kind of tailor some of the knowledge that you may need to help you get started and get going.
So Alex, Andrew posted a couple of great examples in the chat. Not sure if you can see that, but one, a working example of like a dashboard for real-time monitoring of sensors. I think that does come up a lot, like understanding the Power BI, setting up Power BI. Alex is kind of a rock star with Power BI, we've seen with our team. So that would definitely be something that he could perhaps, go through a working example of. I think that's a great idea. And then the second one is storage, under Azure. One of the things with going to the cloud is you suddenly have 500 million options. And I know with data storage, just even understanding what the options are and how you might select, kind of some of the data management tools would be useful as well. Andrew, yeah, so thanks for the input.
So I'm really able to, and really the team, right? So if you're running into a question like dashboarding, KPIs, analytics, trying to understand large amounts of data, leveraging Microsoft's platform. So the Power BI, for example, you saw that during COVID at the beginning, where all these maps and dashboards were being open to the public. But even then, that was very in a protected fashion for the data that it was being surfaced by those reports. So that's an example of an area where I can help you kind of formulate, okay, first, what does it need to look like? And then how do other researchers or your audience, how do they access your information, your reports? What's very key, I'll mention this, what's very key when coming up with any type of reporting offering or solution that you're trying to come up, the key thing is to make sure you understand what's the question you're trying to answer, right? If you properly formulate the questions, then you start looking at, okay, how do I get the answer to that question in a programmatic way? Do I have enough data to answer that question? And then from there is you start figuring out how to show and demonstrate that the data in a way to answer that question. So it helps you to help focus what you're putting together. And that's usually the key when starting up, whether it's a spreadsheet with with charts and graphs, or Power BI, or any other graphing tool that are out there, because I know there's many open source alternatives as well. And really, regardless of the tool, the approach is relatively the same. And I can definitely help guide you through that or help you through that process. The second one is a working example of storage, the first flow. That one I'll have to maybe what I can do is kind of reach out if you want to put your email in the chat, and I can reach out and kind of get a little more context on that question, but I can definitely help you with that, whether it's me or I'll be able to get an answer for you from my team.
That's great.
Oh, go ahead.
Sorry, I was just going to say, just as an example, we've been working with the university to run a kind of 3-part workshop, and it's all virtual, of course. But the first part is like an Azure kind of cloud 101, like basics. The second part is on data. and data management, data storage options. And then the third part is on machine learning. So what we could do with this group, if it's like what would be useful now is to get your input and feedback from your students, researchers, or any of you who are just like, okay, I know all my students know how to use it, but I would really like to get a better understanding myself. You know, send us maybe to Stacy, sort of send us an email. And then we can kind of aggregate that, and then working with Alex, we can decide, you know, hey, let's run an hour session and let's focus on these, you know, 3 topics for the group. So yeah, I think that might be a useful way to see how we can kind of optimize Alex's time, but also kind of give some basic training that would be relevant for those of you that have been using FarmBeats, you know, this summer. Great.
Great.
Thank you, Alex.
You're welcome.
I appreciate it. Stacy, I'll turn it over to you for any final questions or any other feedback we need from this group for next time.
Sure. So I really appreciate Aaron and Alex taking the time to speak to the group. That's just tons of great information and probably a lot more to digest in just a quick sitting. So the meeting is recorded, and I'll post the link up for everybody to access that, either for yourself or for the other folks that you work with. And as Elizabeth was saying, if you have any specific questions for Alex, or even just vague questions, I'm not sure how to do X, we can figure out if it's appropriate to bring it just to have Alex speak maybe regularly at this workshop and spend maybe 15 minutes covering a topic that everybody's interested in, or we break it out into smaller groups if everybody has a question about dashboards or everybody has a question about storage, and we'll just take time to really dig into some very specific questions around Azure. So you can send those my way by email, or in our Teams group, you can post those for everybody to comment on. Oh yeah, I'd also be interested in hearing about that, and we'll figure out how to best use everyone's time. And then for next month's meeting, I know that we had talked about there being a conflict for a lot of folks, and I don't know if others are going to be participating in the event that Dennis had talked about last time, and I had sent a link out in our Teams channel. So how does everyone feel about the date and time of next month's meeting? We usually meet on Thursdays, kind of around lunchtime, but that's conflicting with this meeting. Does anyone have any comments about that? Dennis, did you want to speak just real quickly about what's coming up in September?
Sure. If Tuesday works, it would be good. Let me go fetch again, and I'll put it in chat in just a moment. Sort of the Unlocking the Data Revolution conference site. We are tightening up the set of presentations finally for that. Actually, Ranveer is going to give a keynote on the morning of 24. Well, it'll be morning here. I guess maybe early afternoon out there on the West Coast. So it would be. It'd be great to have this group involved in the conversations and dialogue on those days, 24 and 25 of September, Thursday, Friday. But yeah, if this needs to stay on Thursday, then that's fine too, because like you say, they're being recorded, and those of us that have to miss can catch up.
Sure. Well, this sounds like a pretty big deal, so there's no reason why we can't move it to the 22nd for September. That way everyone is free. We know they're going to be available and no conflict for the conference. So if you want to look in, I'll send out the link again to the event, and you can find it in the Teams channel, and I will move this meeting to Tuesday the 22nd at the same time. Okay, any other questions or comments before we wrap up? Okay, great. Well, thanks everybody. A lot of good information, and we'll look forward to meeting with you again next month.
Okay, great. Yeah, and we would love to roll out the Elata Trellis framework in lots of applications. So that was part of the reason for presenting it here too, just different types of data going in different directions to different clouds, different apps. That's the dream.
Thank you, Stacy.
All right, enjoy your week.
Thanks, Stacy.
Thank you.